So we have paper company has an overhead cost for the $40,000. Each ream costs $3 to produce. They sell each ream for $7. Find the cost, revenue, and profit functions, and then find the break-even point. All right, I'll leave the break-even point to be over there in a second. So we've got our cost equation is made up of our fixed and our marginal. So our fixed would be the 40,000 plus the marginal of 3. Revenue, they sell them for, what is happening with my pen? Revenue, they sell them for $7, so that would be 7Q. And my pen's really freaking out today. There we go. And then our profit function, revenue minus cost. Always put your cost in parentheses. Which would produce, if you reduce that, 4Q minus 40,000. Questions on how I found those equations before I use them to find the break-even point. Cool. So remember, break-even point, you either set the profit equal to 0 or revenue equal to cost. Since we have the profit function, that's usually my preference if I have it. It's freaking out again. This isn't good. So we've got, oh my lord, let me try something real quick. Give me 1 second. Otherwise, we're going to have a fun time of me trying to type things out all day. But whatever works, I guess. There we go. For another couple of minutes before it acts up again. Anyway, since this problem didn't specify, you totally could have used X. So if it specified Q, you'd want to use Q, but here they don't specify any variable, so you can use whatever variable you want. And then we're going to divide both sides by 4, so we will essentially get that Q is 10,000. Now remember, the break-even point is made up of 2 things, the break-even quantity and the break-even price. So this is the break-even quantity. So this is, what are we talking about, reams of paper? So they have to sell 10,000 reams of paper and the price that would be associated with that. So remember, you get to plug in the Q value you just found either into cost or revenue. Remember, we don't plug it into profit because that would just give us 0. And we want to know the actual amount of money they need to spend or get back before they actually break even. So the cost associated with this, the break-even cost would be $70,000. This is a pretty hefty break-even point, but also, while we're talking about this one, just a note. I know it came up on your homework, so hopefully you figured out what it was asking. But so this would mean that they need to sell 10,000 reams of paper to essentially get out of the red. So if I were to ask you how many things do they need to sell to make profit, it's actually 1 more than the break-even quantity. So they would technically need to sell 10,001 because then they actually make, actual positive profit, if you will. I should avoid the word positive profit. What I mean is, you've finally paid off all the things and you can actually keep the money for yourself. That's what I mean. So if you're ever asked, how much do they need to make before they actually make profit, you find the break-even point and then just tack on an extra one. Questions, concerns about that question before we do the supply and demand one? Okay. So radios are us. It finds that they sell 150 radios if they cost $20 and 225 if they cost 10. Find the demand function as a function of quantity, assuming it is linear. So since we want demand as a function of quantity, that tells us we have an f of q, which means that the q value, or you can use x, is going to act as our x value. And so that's going to mean that the price is going to act as our y value. And you could also make that y also. It's just I'm so used to using p's and q's that I just default. So essentially the points we're looking at are the quantity, comma, the price. So we need to find the slope. So you'll get 10 over 75, negative 75, I believe. 150 minus 25. Yep, so 10 divided by 75. You can leave that as a fraction, or this will become 0.13 repeating. Now one thing I want to note, because this will be helpful potentially in the future for your homework, hopefully it balances out a little bit more. But there was a problem on your homework that a lot of people ran into. And I know I said the other day that you need 3 decimal points to make WebWork happy. And that was not a lie. But it also went further than I thought, because I do your homework before I assign them, but apparently I do them in the way that WebWork wants anyway, just because that's how I do my problems. So I didn't realize the potential problems that you would run into. So if this was, say, a WebWork problem and we needed 3 decimal places for each answer, if you're not done the question, take as many decimal points as you can to keep continuing the question. And then at the very end of the question, you can cut all the answers down to 3 decimal places. So like there was one where you had to find the equation of the line. And so if you cut this off to 0.133 and then use that to find the B value, your B value would not, quote unquote, not be correct enough for WebWork, and then it would get angry at you. Yep. So we know the arrangement of the points because of the phrasing that I have highlighted here, function of quantity. So since it's a function of quantity, that tells us we have f of q. So whenever you see function of, whatever, it's a function f of whatever that value is. And remember, when we have that f of q, f of x notation, the thing inside the parentheses is going to act as the x value, and whatever the other value acts as our y's. So since these are always quantity to prices, if it's a function of quantity, the price must be the y value. So we know that it must be quantity, comma, price. So anyway, so to continue this question, I'm going to leave it as a fraction, actually. That's going to be the best way to do it, especially for WebWork, what I was just talking about. So we need to find the B value here. I'm going to choose to use the 150/20 point because that makes me happier. 150 plus B. So 150 times negative 10 over 75. Oh, that comes out nicer than I thought. Then you add 20 to both sides, you get 40 as your, is your B value. Ooh, I did not really space this question out very well. So the demand function should be P equals, I'm even going to leave it as, well, I'll do this so that it's clear for like WebWork purposes. At this point, you could tack it down to 3 decimal places and be perfectly fine. Nope, 40. So if you had used negative 0.133 as your value for the slope when you were calculating this, you would have gotten a B value of 39.95, which is obviously very, very close, but not the same. So that's what I mean when you're doing problems along the way, don't round, try to keep them as long as possible, or especially in fraction form, so that that doesn't mess up your answer and WebWork gets angry at you. If there's also ever a time that you're like, I'm 100% or 90% sure I did this right and WebWork just isn't accepting it, shoot me an email. Don't spend like 5 million bajillion hours trying to figure it out if you're really sure you're right and something's just not working. Anyway, so that would be our demand function. And then if we want the equilibrium point where we're given that supply, let me just write this down so I can scroll down a little bit. So supply was our 800 minus 4Q equals P. I don't care personally, fractions versus decimals. Oh yeah, you could even simplify this. What does 10 over 75 simplify to? 2 over 15. That probably would have been nicer to write down. I personally don't care. I will accept anything that's mathematically correct because I'm more worried about the process instead of how you simplify your answer. So, well, read the instructions to the question. Every once in a while, I might say write your answer as a decimal. So just triple check the instructions of the question. But if it doesn't specify, I don't really care. So if we want the equilibrium point, we're going to set these two things equal to each other, and I'll go ahead and just keep using the decimal value that I have here. Might make our value slightly different. Nope, that should be a Q. So I would add the 4 over to the other side, the 4Q, I should say. Yeah, that definitely can happen on your homework. Minus, whoops, 40. 700, whoop, where'd my Q go? So we'll get 3.687 Q. That's not what that says. 3.867 Q equals 760. 760 divided by 3.867. Q equals 196.53. This is technically radios. So I know you might say, well, do I need to round up to 197 or even down to 196 necessarily? Read the instructions. If it doesn't specify, you can leave it as a decimal. So on your quiz, you can totally leave them as decimals, even though I know half of a radio doesn't make any sense. If it specifies, then do whatever it specifies for. If you just want to round up because it makes more sense to you to have 7 radios, that's fine with me. Just triple check the instructions in case it specifies a specific way it wants the answer. Now, remember, break-even point and equilibrium point are made up of two things. So we have the equilibrium quantity and we need the equilibrium price. So we need to plug this value into either one of the equations that makes me happier. I'm going to plug it into supply because that one makes me happier. We will get 13.88. So the equilibrium price is 13.88. Questions, concerns on that one? Okay, questions, concerns about the warm-up in general. I'll give like 10 seconds, but oh. Where's 2 over 50 coming from? Do you mean the... No, wait, that was a different... No, wait, that was the same question. Do you mean the... Well, that was supposed to be 10 over 75? Rihanna? The slope. So... You can reduce it. It would reduce to 2 over 15, though. But anyway, I think someone else has the same question as you then. So you were a little off because you left them as fractions. That's perfectly fine. Okay. So the thing is, with actually fractions is almost the better way to go here. If it's a question for me on a quiz or an exam, it's not going to matter. As long as you do the process correct with a relatively correct answer, you're fine. Fraction, decimal, I'll be able to follow what you do. I'll know the different answers that they should have. You should be a little careful on web work. And again, if you are pretty sure you did it right and web work's just not accepting it, just let me know and I'll figure it out. But on a quiz or exam, even if, so if we use the actual 10 over 75, the 215, you would have gotten 196.5517, blah, blah, blah. And then 13.79, blah, blah, blah. Those are also perfectly, oh yeah, sorry. When I said 15, that possibly could have sounded like 50. But if you would use the fraction, you would get, no, oh my gosh, I keep thinking I select the highlighter and I don't. You would get answers more like this, which notice are very, very similar to the answers that I have. So it's fine. On a quiz or an exam, those are perfectly acceptable answers because they use correct values. If you found the other way because you took the decimal way, that's also perfectly fine. Okay, so other question. So yeah, so the equilibrium point is technically these two values together. And what the equilibrium point represents is it's essentially the best option that a business can have because that's essentially, it has nothing to do with profit. Let me say that. We don't know anything about the type of profit they're making at this point. All this is telling us is that if we sell these things for about $13.88, which will mean that we will sell approximately 197 radios, then we have just as much supply as is going to be demanded. So we're not going to have radios left over. We're not going to have people who want a radio and can't have a radio. It's essentially we are going to be able to create as much as we sell. And this is the price that we need, the price and the amount of items that we need to have to be able to have that happen. So that's what the equilibrium point is representing. Let me triple check. Yes, Gabby. So the equilibrium point would be the 196.53, comma 13.88. So the demand function is the the demand function is the thing you wrote, Rihanna. And then the equilibrium price is the 13.88, yes. And the equilibrium quantity is the 196.53. Oh, on the quiz. So on the quiz, when I ask for a break-even point, I give you two blanks, one for the quantity, one for the price, and then the equilibrium one, I actually don't ask for the full point. I just ask for one of the two values. So you just put the value I want in there. So when I ask for the full point, I give you two separate blanks to put the quantity in one and the quantity price in the other. Any more questions? Okay. We don't have much time, but we've got to squeeze a little bit of notes in here. I might need to adjust your homework because we might not be getting done as much as I think. Okay, so where were we at? Okay, so I need to go over this question again because we kind of breezed through it very quickly. So we're talking about exponential functions now, remember. And exponential functions are different from linear functions. So linear functions have a constant slope and exponential functions have a constant factor. So to find that constant factor, we have two things that we can do. The one of them is what we have written down here is if x or whatever is representing your x value are consecutive, just divide the y values. Okay, and that's what we were doing here. Since all of these values were consecutive, we were just taking their their y values and dividing them. Now the important thing is you always need to put the y value of the larger x value first. Okay, so the larger x value has its y value going first. And the reason I phrase it like that is because I don't want to say the larger y value because that's not necessarily true. It is the y value associated with the larger x value. And the point is, once you find all of those ratios, you check to see if they're the same. So you know how with the slope, we were taking the change in y over change in x and seeing if they were the same number? Similar idea here. We're taking these ratios of these y values and seeing if they're the same number. Note how those are not the same number that we calculated out yesterday. 1.285 is not the same as 1.3 repeating, is not the same as 1.2916 repeating. So we did come to the conclusion that this data was not exponential because the factor is not constant. Now there's a couple other things I want to talk about in terms of this question. What if the values aren't consecutive? Because here all of our t values were consecutive. What if they aren't consecutive? So if they aren't consecutive, whoops, if they aren't consecutive, here's what you need to do. It starts off very similarly, where you still find the ratio of the y values. And now I'm running out of space, so I'll just have to write it like this and let me explain it in a second. The change in xth root. What the heck do I mean by that? Give me a second. So let me squeeze that in over here. We got a lot of information on this one question. So let's say I wanted to find the factor between t equals 1 and t equals 5. Okay? Because I can technically take any pair of numbers on this table and still look for the factor. So say I wanted to go between t equals 1 and t equals 5. Well, that means the change in t value here is 4, because 5 minus 1 is 4. How far apart are those numbers? So if I take their y values and take that ratio, 40 divided by 14, I still take the y value associated with the larger x value first. But now what I want to do is, so essentially what happens in an exponential function is we multiply the previous number by some factor to get the next number. So if I go from 1 to 5, I must have multiplied by that number 4 times. So to essentially try to undo that multiplication by that same number 4 times, we need to take the fourth root of this. Now, if you're trying to type this into a calculator, my personal preference, there is a way to actually put in the root, but it is equivalent to a fractional exponent of 1 over the power of the root. So if you take your calculator and you say 40 divided by 14 to the 1/4 power, it's the same as the fourth root. This would be 1.3. 1.300 blah, 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 but 1.3. And this number is the same thing. This number, I should be careful with the word same thing, is also a number that you would compare to the other factors. Okay? So if the x values, t values aren't consecutive, you have to take this kind of extra step of taking a root of the ratio. Now that still tells us that it's not exponential because still those numbers don't agree. One last thing I want to say about this question. I think I already said that, but now I mean it. Let me try to squeeze this up here. We will want factors to match up to, I'm going to say 3 to 4 decimal places. What I mean by that, I'll let people write that down for a second. I'm going to do this in a different color so that you know that it's not actually about this question. So say the factors that we got by doing these ratios was 1.1715, 1.1712, and 1.1716. Say those were our factors that we found by taking these ratios. Since those numbers match up to 3 decimal places, we're going to say it's good enough. And we're going to say it's probably, it can be at least estimated using an exponential function. So as long as the factors match up to 3 or 4 decimal places, even if the rest behind that doesn't match, we're going to take it to be good enough and say it's exponential. In this case, that still doesn't work because they were different up to the first decimal place. One was 1.2 and the other was 1.3. But if they are similar up to 3 decimal places, we will take that to be good enough and call it exponential. Questions, concerns on that? Okay. This next question is pretty quick, so I would like to go through it so that we can just say we did another question. So we have grades if 6 students are given by the equations below, where the time t is measured in weeks after the first midterm exam. So here we all have we have our exponential function. So remember, those are all taking the form of this, where this is an initial value, and the a value here is called the base. And a reminder, if a is greater than 1, we have growth. If a is between 0 and 1, we have decay. So say we're asked, Alex's grade has been decreasing since the first exam, which formula or formulas could represent her grade and why. So if we want a decreasing value, we want exponential decay. So we want a to be between 0 and 1. And this is what I'm taking to be the y. So I'm not going to write any more of a y than that. We need exponential decay, so we need a to be between 0 and 1, which would mean that our options are either option 3, option 4, or option 6. So 3, 4, and 6 are the possible options for a grade that is decreasing over time. Specifically because they represent exponential decay functions because their a value is less than 1. Which student's grade is falling the fastest? We essentially want the smallest a value, which would be the largest decrease. And so the smallest a value is option 6, 0.89. If we then have Umar's grade has been rising since the first exam, which formulas could represent his grade and why. So if we want rising, we want exponential growth. So we want a to be greater than 1. And again, this is going to be our y part of the question. So which of these values have an a greater than 1? Option 1, option 2, and option 5. Essentially all the options we haven't already talked about. So option 1, option 2, and option 5 all have an a value greater than 1. So it would represent exponential growth. So that would mean that the value is rising over time. Which student's grade is rising the fastest? That would be the largest a value, which means the largest increase. So the largest a value here is the 1.05 associated with option 2. And then the last piece of this question is Karan's came out to have an 85% in the class. Sorry, came out of the first exam with an 85 in the class. Which formula or formulas could represent his grade? So since the first exam was an 85 for him, that means that the initial value would be 85. So out of these options, which are the only options that have a initial value of 85, is option 4 and option 6. So options for his grades would be either option 4, or option 6. Questions, concerns on any part of that question? All right. Your quiz should be up. Let me triple check to make sure it's there. Got 15 minutes left in class. Shouldn't hopefully take longer than that. Remember, the time limit is unofficial. If you're going to end up taking more than 20 minutes, just hit the cancel button in the little box that pops up and it'll let you keep going. So if your time, quote unquote, runs out, just hit cancel and it'll let you keep going.